this video, we will be seeing about single source shortest path problem. It is also called as Dijkstra's algorithm. So in this algorithm, we'll be finding out the shortest path from a given node to rest all nodes. Okay, so the algorithm, the working of the algorithm is like this. It finds the shortest path from the source to the nearest vertex, and then the second nearest vertex, and so on till it finds the shortest path from a single source to rest all vertices in the graph. It is applicable both for directed and a directed graph, but it is we need to see that the weights of the graph should be positive. It is the algorithm is not applicable if the weights in the graph is negative. So it is applicable for directed and undirected graph with non-negative weights. So the algorithm is like this. We consider yes to indicate the source. We indicate set of all vertices. The first step will be identifying the distance to I, which is caused from source to vertex I. Then we'll select W, which is minimum of all the DWs, and we go on updating the S set, and we'll be reducing the V set. So here this is the cost adjacency matrix. The distance from vertex 1 to itself is 0. So distance from vertex 1 to 2 is 2. So here you can see distance from 1 to 2 is 2, and there is no direct edge from 1 to 3. So the distance from node 1 to node 3 is infinity. There is no direct edge from vertex 1 to vertex 4. So distance from vertex 1 to 4 is infinity, and 1 to 5, there is a edge connecting node 1 and 5. So this distance is given as 10. Again, from 2 to 1, because it is undirected graph, the distance from 1 to 2 is same as distance from 2 to 1. So distance from 2 to 1 is 2. The node to itself is 0. 2 to 3, the distance is 5. 2 to 4, the distance is 3. And 2 to 5, there is no direct edge connecting 2 and 5. Therefore, the distance is indicated as infinity. So in this way, we'll be writing the cost adjacency matrix. So the cost adjacency matrix will indicate the distance from any node to any other node in the given graph. So the first step here is we consider yes, let 1 be the source vertex. So yes is 1. V gives the set of all vertices. So it is 1, 2, 3, 4 and 5. So what we need to find? First we need to find di's, which is cost from S to I. So we know the distance from any node to itself is 0. So we will not find D1. D2, it is cost from 1 to 2. What is the cost from 1 to 2? It is 2. Then D3, it is cost from 1 to 3. Cost from 1 to 3 is infinity. D4, cost from 1 to 4. Cost from 1 to 4 is again infinity. D5 is cost from 1 to 5. So cost from 1 to 5 is 10. In the next step, we will be finding out minimum of DW. So we have found out all DIs. Among this, which has the minimum weight? So here if you see 2 is the minimum weight edge. What is the node corresponding to it? It is D of 2. So the W here is 2. 2 is the minimum cost edge, and the node corresponding to it is 2. So W is 2. So next what we do? From V, we remove V minus S. We will be adding W to S and removing S from V. So in the first iteration, what we have here, source is 1, there is no W which is found out. So D2 is distance from 1 to 2, that is 2. D3 is infinity, D4 is infinity, D5 is 10. So next, in the next step, what we are doing, we identify W as 2 and we will be adding W to S. So S will be updated as 1 and 2 and we remove S from W. So we will be removing from 1, 2, 3, 4, 5. We will be removing 1 and 2. So the left out vertices will be 3, 4, 5. Right? So now we have identified W. So next we need to find out dV, which is minimum of dV or dW plus cost from W to V. That means in this iteration we have found out the nearest vertex from the source vertex, which is the source vertex 1. We have found out the vertex which is nearest to it. We have considered the edge which has least cost, that is 2. So the corresponding vertex is the nearest vertex to the source. So 2 is the nearest vertex to the source. In the next step, we will be finding out the nearest vertex to node 1 through node 2. So using 2 as intermediate, we will be finding out the nearest vertex to 1 as using 2 as intermediate node. Okay, so the next step in the second iteration, what we will be doing, now our dW, we know dW is, it is d of 2. Okay, so the distance from 1 to 2 we have found out. So 2 is the nearest vertex as of now, and using 2 as intermediate, we need to find out the distance to rest all vertices. So which are the rest all vertices? V is 3, 4, 5. So what is dV? D3. It is minimum of D3 or it is dW. What is dW? D2 plus cost from 2 to vertex 3. Right? So what is this? What is D3? We can obtain D3 from here. It is infinity comma D2. What is D of 2? D of 2 is 2 plus cost from 2 to 3. Cost from vertex 2 to 3, which is 5. So among infinity and 7, which is minimum? 7 is minimum. So what this indicates, the distance from 1 to 3 using 2 as intermediate node is 7. So now initially the distance from 1 to 3 was infinity. Now we have updated using 2 as intermediate node, the distance is 7. Next, D of 4. So V is 3, 4, 5. So we'll be finding D of 3, D of 4 and D of 5. So this is minimum of D of 4, comma, dW plus cost of W to V. So dW is 2 plus cost of 2 to 4. So from this table we can identify D of 4. D of 4 is infinity. D of 2 is 2 plus cost of 2 to 4. Cost of 2 to 4 is 3. So it is 5. Next, D of 5. This is minimum of D of 5 or D2 plus cost of 2 to 5. So what is D of 5? It is 10, comma, D2 is 2 plus cost 2 to 5. 2 to 5, the cost is infinity. Among these two, which is minimum, it is 10. Now we see the distances are 7, 5 and 10. Among these three, which is minimum? 5. So this distance is minimum. We will be identifying the node corresponding to this distance. So dW is dw now is minimum of d3, d4 and d5. Which is minimum of d3, d4, d5? It is 5. So the node corresponding to it, w is 4. So we'll update this. So initially we found out w as 2 and that this distance was 2. So here we have updated d3 is 7, d4 is 10, d5 is d4 is 5, d5 is 10. So in the next iteration we will be updating w as 4. Okay, so now we will be adding this w to s. So s is updated as 1, 2 and 4. Right, now v is v minus s. What is there in v now? 3, 4, 5 minus s. Yes, and now we have updated s as 4 is included in s. So from this we will be removing 4. So it is 3 and 5. So it can be written as 1, 2. So here it is 1, 2 and 4. So we'll be removing 1, 2 and 4 from here. So 3 and 5 will be left out. Right? So now using 4 as intermediate node, we need to find out the distance to 3 and 5. So here w is 4, v is 3 and 5. So this time we need to just calculate distance to 3 and 5, which is minimum of dv. What is dv here? d3 comma dw. W is 4, therefore dw is d of 4 plus cost from w to v. Cost from w to v. So it was close. So it is cost from 4 to 3. So this is minimum of d3 is 7, d4 is 5 plus cost from 4 to 5. Cost from 4 to 5 we will be finding from cost adjacency matrix. Cost from 4 to 5 is 6. So out of these two, which is minimum? 7 is minimum. Then d5, this is minimum of d5 comma dw. W is 4 plus cost from 4 to, so this is cost from 4 to 3, which is 4, 9. So 7 is minimum. So this is cost from 4 to 5. It is minimum of d5. What is d5? 10 comma d4. d4 is 5 plus cost 4 to 5. 4 to 5 cost is 6. Out of these two, which is minimum? 10 is minimum. So now again among these two, we'll have to find out new w. So among 7 and 10, so the w is minimum of d3 and d5, which is minimum of d3 and d5. dw is minimum of d3 and d5. Minimum of d3, d5 is d3. Therefore, w is equal to 3. Then again we will be updating v as 1, 2, 3, 4, 5 minus, now it is 1, 2, 3, 4. Left out will be 5 alone. So we'll update the table as well. d2 remains as it is 2. Now we have updated 3 remains as it is 4. Here we have found out it is minimum, that is 5, and 10 also remains the same. So now we have included which vertex? Vertex 3 into S. So here in this step we have found out WS3, update S. Now it will be 1, 2, 3, 4. In the last iteration, now W is 3, V is 5. V has only one vertex, 5. Okay. We will be calculating D5. It is minimum of D5, DW. Now here is 3. So it is D3 plus cost 3 to 5. So what is the cost 3 to 5? It is minimum of D5. D5 we can get from this table. It is 10, comma D3. It is 7 itself. Then cost 3 to 5. So that we will be taking from the cost adjacency matrix. Cost 3 to 5 is 2. So we'll be updating this 7 plus 2. Now among 10 and 9, which is minimum, 9 is minimum. Therefore the last W here is 5. We don't have any other vertex. So minimum is 9 itself. Corresponding vertex is 5. Now V is V minus S. So all the vertices now we'll add W to S. So updated. First we'll write down all the distances. 2, 7, 5, and now it is changed as 10. Now update this. V minus S. 1, 2, 3, 4, 5. Minus S we have updated. 1, 2, 3, 4, 5. So it is null set. So update this. 1, 2, 3, 4 and 5. Our new W is 5. So finally we'll write down all the distances at each step whatever we have got. Initially 2. Then for 3 we updated. It is 7 itself. Then 4. The distance was 5. Finally we updated this one. It is 9. So this is the final table. This is the final table. So S now includes all the vertices. That means from the source we have identified the distance to all the vertices, and the distances are from 1 to 2 the distance is 2, from 1 to 3 the distance is 7, from 1 to 4 the minimum distance is 5, and from 1 to 5 the minimum distance is 9. So I'll summarize everything once again. Initially we find out the distance from source to its immediate neighbors. So we have found out the distance from 1 to 2, 3, 4 and 5. Among all this, we identify the nearest vertex. Nearest vertex in the sense the edge which has minimum weight, that is 2. And we take the corresponding vertex. The corresponding vertex is 2. So that we indicate it as W. Next we add 2 to S. So initially S was just 1. Now we have added 2 to S. So S becomes 1 and 2. And then we write down all the distance whatever we have got here. Then we update V as V minus S. So set of all vertices minus whatever S we have updated. So the new V will be 3, 4 and 5. So the dW is d of 2. The distances, whatever d's we are getting, that we will be calculating from this, will be obtaining the values from this table. And the cost adjacency matrix sees whatever we are getting, that we will be accessing from cost adjacency matrix. So in the next step, V is 3, 4, 5. So we need to calculate D3, D4 and D5. Apply the formula. It is minimum of dV, dW. So W here we have identified as 2. So it is D2 plus cost W2V. W is 2, V is 3, 4, 5. So initially we have taken 3. So it is 2 to 3, 2 to 4, 2 to 5. So D3 we get from this table. D3 is infinity and D2 is 2. Cos 2 to 3 is this one. 2 to 3 is 5. So that way we identify all the distances. Among this we identify minimum DW. So among 7, 5 and 10, which is minimum, 5 is minimum, the vertex corresponding to that distance is 4. So the new W will be 4. Next we update S as 1, 2 and 4, and the distances also we will be updating. So it remains, so 3 has changed to 7. I mean, this infinity has changed to 7. And here also D4 infinity is changed to 5. 2 and 5 remains the same. So in the next iteration, using 4 as intermediate node, we will be finding out distance to rest other nodes. Which are the rest other nodes? 3 and 5. So this time W is 4. So we find D3 and D5 using 2 as intermediate. So now among these two, which is minimum? 7 is minimum, and the vertex corresponding to this distance is 3. So the new W will be 3. So we update this as 1, 2, 3 and 4. And here the values also we have updated. It remains same as the previous iteration. Finally, we are left out with vertex 5, and we'll be finding out D5. This time using 3 as intermediate node. So when we calculate, we obtain the distance as 9. Finally, we add 5 also to S. So it will be 1, 2, 3, 4, 5. And finally, we have updated the distance as 9. So at last, we write down all the distances from source to rest all vertices. Thank you.